My name is Mike McDonald, and I'm a product manager on Google Cloud Platform. I've worked on Firebase for about 5.5 years, so I've been building mobile apps for a long time. And today, we're going to go through a couple of the kind of best practices that I've seen that build secure apps. And kind of conversely, I've seen a lot of insecure apps, right? I've seen websites that I can go to and download an entire database just because they didn't follow a couple really simple tips. So first of all, just to level set, how many people have used Firebase, or how many people have heard of Firebase to start with? Great, awesome. How many people have built an app and shipped it on Firebase? Okay, about half the room. Awesome. So if anyone needs to, feel free to run out of the room and just start screaming if you see something that you're doing wrong. And then, we can hopefully fix that really quickly. Otherwise, for the rest of you, hopefully it's not too repetitive, but we're going to go into a lot of really in-depth examples of how to build secure apps on Firebase. So hopefully this isn't too old hat, but if you wanted to build a kind of traditional mobile or web application, you'd build something like this. So your mobile app or your browser talks to a web server, and that web server is, say, running Python and Django, or maybe it's running Ruby and Rails, things like that. And within that server, not only are you doing the business logic of what your application does, but there are a lot of ambient concerns that you have to deal with. You have to authenticate your users. You have to make sure they're authorized to do what they're allowed to do. Maybe you have to validate schema because you're writing to a database or some other API. And then you have to deal with a bunch of other things of just running and managing infrastructure. So, doing OS or language runtime updates, unless you're using some serverless compute, maybe you're not doing that. But the point is, there's a lot of stuff going on that is not directly related to what your application is doing. And so that's the whole premise of Firebase, right? Firebase is eliminate that middle tier server and let your applications talk directly to managed infrastructure. So let them talk directly to a database, or let them upload a file directly to a cloud storage bucket. And that obviously presents a lot of issues, right? Like untrusted clients on the internet. The internet is a very scary place if you haven't already spent a lot of time there, right? There are, if you just look at web server logs of a web server that you run, say on a GCE instance, you see IP addresses coming from all over the world, right? People are doing malicious things on the internet. You want to put yourself kind of ahead of the rest of the internet by doing a couple of really little things to really make yourself secure. So we're going to go through those tips by building an application, right? So we're all at a conference. I did not travel very far. I live in the Bay Area. But I'm sure many of you are here, and you have to expense things, right? So I don't know how tedious of a process it is at your companies, but some companies, you have to fax receipts in. It's terrible. We want to build a better expense reporting experience, right? So I want to take a photo and have that photo somehow magically become a number, right? We can use fancy machine learning things. I've heard a lot about that. And we'll actually use Firebase to build this experience. I think we can do it really, really quickly. So I have myself, and the first thing that I need to do when I'm building an application, and we're talking kind of any normal application, I need to authenticate myself. I need to say, hi, I'm Mike, and I need some way of actually proving that. So I can get information about myself, and then I need to upload that photo. And so we're living in a Firebase world. I can use cloud storage for Firebase and suck that photo right up off my device and drop it in a cloud storage bucket. And then we can use the magic of Cloud Functions. So Cloud Functions are kind of event-driven compute off of various services. So whenever an object is dropped in my storage bucket, I can trigger a function. And then I'm not a super savvy developer. I'm just going to call the Cloud Vision API. I'm not going to write my own OCR or any of that. I'm just going to let Cloud Vision OCR it. And my function will get the response, look for the largest dollar value on a receipt, and then write that information to Cloud Firestore. And then Cloud Firestore, maybe we want to say aggregate over the total sum of my expenses so that I can get that number. So maybe that'll trigger another Cloud Function. That Cloud Function will do a sum, write back to Cloud Firestore, and then notify me, the user, in real time of, hey, you've uploaded this expense, your sum is now X. And normally, you could build this app where your file storage is public on the internet, and your database is readable or writable by anyone. And those are obviously very bad things. So let's walk through how to not do that. How to kind of do that security as we're building the application. So my tips are structured. We're going to talk about a tip, and then we're going to talk about the mitigation along the way. So as I mentioned, the internet is a very scary place. You should never trust things on the client, because your clients can look something like this, right? If you've built a web app on Firebase, I'm sure you've copied and pasted this config snippet a million times. It literally has an API key, the location of all of your resources, et cetera. And if you leave your resources public on the internet, someone can do that. And they can just say, oh, I'm going to just write to your database anywhere. So you really can't trust the client to do anything securely. We've provided a number of tools in Firebase that help mitigate these risks. But I get this all the time. People are like, oh my god, this is scary. This is out in the world. Like, yes. And it's by design. And it's not a problem if you follow the rest of the tool or the tips in this presentation. So the first of those is, right, I just said trust nothing. But we have to trust something, right? Otherwise, we can't really do anything. And so the way that we do that is via Firebase Authentication. And so we're going to go into a brief, I guess we're going to explain how Firebase Authentication works and why we can trust it and kind of use that as the root of trust for the rest of our application. So how many people have signed in via Google? I would assume almost everyone in the room. Great. If anyone has looked at the information that you get back information like a user ID, you get a profile picture URL, you get obviously your Google ID. And you can imagine a world where you want to say talk to Firestore, and you just pass along those claims. You're like, hey, I'm Mike, you know? And Firestore is going to be like, wait, like anyone could say that they're Mike, right? That doesn't make sense. And so identity providers have taken to providing you an access token. So if you've ever done OAuth programming or similar, you get this access token. And that's this kind of opaque string that just represents you. And we can actually take that and Firebase Auth, we can kind of pass that along and say, hey, I've signed in via Google with this access token. And Firebase Auth can say, hey, Google, like, is this actually a valid access token? Has Mike proven that he is who he claims to be? And Google will be like, yep, you know, I can verify that that access token is correct. And Firebase Auth will say, OK, great. Mike has signed in with Firebase Auth. Let's actually give him a user ID in Firebase, right? Because we can have people sign in via Google or Facebook or Twitter or a custom provider. We kind of need some standard that we can all rely on within the Firebase products. And so we'll give you a UID. And that also allows you to do things like a user signs in anonymously, and then we can upgrade them as they sign in and merge those accounts. We'll give them a user ID. And we will also say, hey, take this other cryptographically signed token. So if folks are familiar with a Json Web Token, we give you this Json Web Token that says information about that user. So it looks like this. It's this long, kind of seemingly opaque string, but it has three important parts. It has a header, and that basically says, this is the algorithm that was used to sign the token, et cetera. And then this is the juicy part. It has a body with a bunch of data. And that data has all the same kind of provider-specific information. So things like the name, the email, the name of the application used, and then some other custom claims, like, hey, I signed in via Firebase, here's my Google, or I signed in via Google and Firebase, here are my various emails. And then it has, and this is the most important part, it has a signature. So there's no prior knowledge of cryptography necessary, don't worry. But basically what happens here is Google has a public-private key pair. So one thing is secret, your private key, and then we offer a public key for verification. And Firebase Auth will kind of translate that Google credential into a Firebase Auth token that it signs with its private key. And so it basically signs the header and the data and puts that in a signature. And so if someone comes along and they change, they intercept your token, and they try and change it, that signature no longer matches. And when Firestore or Cloud Storage or any of those Google properties will try and understand that token, they'll say, hey, something's wrong, the signature doesn't match. And so that is kind of where our root of trust comes from, right? And it would be obviously very bad if those private keys leaked. And so we rotate them and we do all of those security things so that you are not trying to build your own identity provider. Don't roll your own crypto, don't build your own identity providers. There are lots of people who have done this. So we have done the mistakes so that you don't have to, and then we fix them along the way. So now when I want to go and query Firestore, I can say, hey, here's my Json Web Token. Pass that along, and then Firestore knows how to validate that and pull a bunch of claims out of that. So there you go. It can say, awesome, you're Mike, you're this user ID. Here are all the properties associated with you. Which gets us to our next part, right? So we know who our users are, and we can verify and trust that they are who they claim to be. But there are a couple of other steps, right? We've done our authentication of just, yes, you are who you claim to be. But now there's the authorization step of, can you do the thing that you're asking to do? And then, because again, we don't provide you a server to do all these things, we have to say, OK, how do you do schema validation? So when you upload a file, it looks like a certain way. Or how do you do business logic to validate that someone isn't inputting malicious data? And that's where security rules comes in. So Firebase security rules kind of stand between your client and the backend that you're accessing to provide you those additional features. And it does so via this thing called attribute-based access control. So some of you have probably heard of role-based access control, and we'll talk about that a little later. But attribute-based access control is just, here are a bunch of properties. So the user ID, the request that you're making, the resource that you're accessing, go and derive some decision based on that. So we'll walk through that. Hopefully some of you have seen this before, but if you haven't, not a big deal. We typically start by defining a service. We're writing rules on storage, and then we offer this kind of match construct. And so we say, if anyone, for instance, has used the RESTful APIs for Google Cloud Storage, storage.googleapis.com/b/the name of the bucket /o/the path to the object, we're just doing the same thing. We're saying, OK, let's match kind of a RESTful path or the resource that you want to access. That little squiggly character is a wildcard. So in this case, we're going to say, hey, match the bucket in your project. And similarly, we can say, OK, let's imagine that we're naming our the images that we're uploading to cloud storage for Firebase. This users, the name of your user ID, expenses, and then expense.jpg or expense.png. And then I can do these allow constructs. So I can say allow a read or allow a write if some condition is true. And this is the attribute-based part that I was talking about earlier, because those attributes could be if the user matches the user ID that we're here, or a number of other things. So we'll start with the first one, and we'll say only let a user read their expenses or write their expenses. So this request.auth.uid, we're basically pulling a field out of the token and matching it to a name of the file. And then we can make it a little more complicated, right? We can say, OK, any user can read only their documents or only their expenses, but now we are going to enforce a few more constraints on writes, because we don't want someone uploading a 5 gigabyte tarball. We want someone uploading a thing that has to be an image less than a megabyte. And again, we can pull in those attributes and make decisions based on that. And then lastly, we can enforce certain pieces of business logic. So imagine you don't want to allow an expense to be overwritten, because maybe someone is trying to change it to look differently after the fact. They've photoshopped it to have a different value. And so we're going to say we're going to require that they can't overwrite their object. So if there's already an object there, we don't let them write it. So that's kind of a very simple example, but hopefully it shows you the power and flexibility of these rules. OK, so we've uploaded our file. We've done so because we authenticated. We wrote some rules to ensure that it's the correct thing. Now we trigger our function. And so our function could look something like this. If you've ever written Cloud Functions for Firebase, you pull in this Firebase admin library. We'd also pull in a Google Cloud Client library for Vision. Right, we're going to make one call out to the Vision API to OCR. We are going to write a little bit of code that says, hey, find the biggest number on the screen. And then we're going to write that out to Cloud Firestore. And the one thing that I really want to emphasize here is we're actually running as an admin. So this function is kind of not running as an end user. It has a higher level of privilege. And it's actually running using a service account. Right? So we signed in our users with Firebase Authentication, but all of our compute is running as this kind of robot service account user. And that uses Google Cloud IAM. And so historically, inside of all of your functions, all of those functions run with the editor role. We kind of have one identity, and they all get editor. So that means that if you screwed up your programming and maybe there are cases where someone uploaded a source code file and your function evaled it. Potentially, that function could now create virtual machines, or it can't change IAM roles, but it can build other resources or do things that it really shouldn't be doing. Right? All our function needs is this concept of least privilege. Right? It needs to read from cloud, read from cloud storage to do a vision check, and then write to Cloud Firestore. So we have this concept of per function identities, and what that means is you can create a new service account and have that be given just the amount of privilege that it needs. And you can do that via custom roles in IAM, or minting access tokens if you're accessing, say, the Google Drive or Google Sheets APIs. So we'll walk through that. So I have a function. It was called OCR receipt, because that's what it does. It OCRs a receipt. And I'm going to create a new service account to represent the identity of that function. And then I'm going to create a custom role. And I'm going to call that role, only the Cloud Vision and Firestore thing. And I'm going to pass it 2 permissions. And this is a little counterintuitive. Vision actually needs object get because we're pulling from GCS. And then the only permission that it needs to write to Firestore is, again, sort of confusingly, data store entities create. There's a bit of legacy there. But we've now gone from editor, where it could do anything in our project, modulo a few things, to exactly 2 permissions. And then we are going to actually grant that new role to our identity. And then we're going to redeploy our function with that identity. So now we've, again, gone from this incredibly overprivileged role down to exactly the 2 permissions that we need to read from Vision and storage and then write to Firestore. And then one of my other favorite things, so Vision, you may have noticed, doesn't actually have an IAM role. So it relies on OAuth scopes. And so you need this scope, for instance, the Cloud Vision scope. And so we'll give it the Cloud Vision scope, and it doesn't fit on the screen, but we'll give it the Cloud Storage scope as well, so it can go in right there. And we can use this cool thing called the Metadata Service. So the Metadata Server, Metadata Server, not service, basically is an HTTP server that kind of looks like it lives on your compute instances. And what it will do is it will fetch tokens for you. So when you deploy, right, like how many people, and be totally frank with me, like how many people have uploaded a service account to their compute? Just like, or like occasionally you upload it to GitHub because you screw up. I've done it, it's terrible. Yeah, I see a couple hands on that. Yeah, that's not great development practice, right? Because maybe your private repo becomes public, or somehow those credentials leak. The point of the metadata service is that you don't have to ever deal with credentials. You can just say, hey, metadata service, give me a token, and we refresh those tokens every half hour or an hour, so you're not touching credentials at all. You can just say, this is my identity, give me a token for the identity. And so that's what we're doing here. And we're actually even saying, give me a token that's scoped only to the 2 or 3 services that I need. And I can make that request, get the token, and then do my calls. And under the hood, our client libraries are doing this for you. I just wanted to be very explicit. Hey, this is a really cool functionality, a piece of functionality that we've provided actually just recently. OK. So we've kind of gone through half of our flow, where we've been able to securely upload a file and then run some things as admin securely before writing back to Cloud Firestore. So the storage rules that we wrote, I would categorize as pretty simplistic. If you've ever written Cloud Firestore rules, they're a little trickier. So we're going to go through some similar concepts and then see kind of how we extend that into the future. So as I mentioned, and this is going to be kind of a slight point of difference, that write that we did from the function happened as an administrator, which means that actually a bunch of these rules are not enforced, right? Because we go through IAM, and we do an IAM check that says, hey, your function is running kind of as an administrator. Let's check there. This is mostly, the Firebase rules are mostly for your end users, and they're kind of designed purposefully for that. But I'm going to go through an exercise of, we also want to ensure that maybe there is a category of user who is writing their expenses directly to the database. Maybe we have a mode in our app that you don't have a receipt and you just have to put in the amount manually. We still want to provide for that, so we would have to kind of write that schema out in our database. And also, it's just good practice to see people walk through this. So we'll start off with kind of a similar set of constructs that we had earlier. Right? You have a service, in this case it's Firestore, and you have that kind of similar boilerplate path of databases, documents, etc. For those of you who haven't used Firestore, it's a document collection database. So you have collections, for instance, expenses, and then a document named the expense ID. So expense.jpg or whatever. And we're going to say we actually care a lot more about schema validation. So imagine we kind of did the authentication check, and we did a if the user can do whatever. We want to validate, for instance, that unlike just the file name, like we have in storage, maybe our documents have to have certain properties. So in this case, we're actually going to write 3 properties: the image URL, so we could pull down our file and display it in the app; the amount of money; and then the user ID of the user that actually wrote it. And so the first thing that we did was we basically said, this document can only have those properties. That's what that has only check is. And the next thing that we're going to do is we're actually going to type check those. We're going to say, OK, the image has to be a string, because it's just a URL out to storage. The amount has to be a number. and the UID also has to be a string. It's just a Firebase auth UID. So we've done just simple schema validation, but then we can do some more complicated things. We can say, for instance, the image URL has to match a certain regular expression. So only allow them to store images that are stored in cloud storage for Firebase. Or maybe we don't allow receipt expenses over $1,000, right? We're like, whoa, you shouldn't be doing that in our mobile app, so we're going to limit that. And the last one that we want to do is kind of that quick auth check of the user who's writing this document has to actually be that user, right? I don't want to impersonate you. I don't want you changing my document later, et cetera. And then if we wanted to, kind of for completeness, we could say things like allow update, allow delete, et cetera. If a rule is not specified, everything fails closed, right? That's how this whole thing works. So don't worry, your entire database is not public on the internet unless you do something like, say, allow reads and writes everywhere, which, that is an option when you start in test mode. You can say, yes, allow everything to be public on the internet because it's really fast to iterate. Not great development practice. And I'll get into some ways that we can help kind of make that easier in the future. But there's another tool, right? If you're looking at that and you're going, oh God, I have model classes with 15 or 20 different properties and I'm storing them in Firestore. This is going to get crazy to do that all manually. Do we have the tool for you? So I always feel kind of funny. I work at Google. I've worked at Google for a while. Has anyone heard of protocol buffers? A couple people? OK, it's a Google conference. I guess it kind of makes sense. So protocol buffers are basically a way of defining a schema independent of a programming language. So it's an interface definition language. So I can define an expense proto. And I can say, hey, that has a string, image URL, an amount of money, and a UID. Those fields are all required. Maybe actually, I should have made image URL optional because, maybe we have people typing in expenses manually. But you can actually generate a bunch of things from that. For instance, you can generate all of your classes for your model objects. So for instance, it would create expense.java. And it would create, expense.swift and TypeScript and whatever other languages. And we've extended it to also create rules to validate those model objects, right? So what happens here is your flow is you define your objects in protocol buffers, and then it generates the model objects on your client as well as the rules on your server to validate those model objects. So if you're always deploying those things in sync, you should never get to a point where things are kind of egregiously broken in your data model because you should never be writing those things. So definitely check that out. It's just kind of an open source tool. You can run it yourself, and it will generate all of the various model objects that you want, as well as rules to validate them. And that makes it a little easier, right? Because now you just say, oh, is this an expense? And pass it in. And it's like, yes or no, it's an expense. You still have to include whatever kind of other business logic checks you have. We're actually investigating. Imagine if we go back, and instead of just saying what they are, imagine if you could specify conditions in a proto as well to say, hey, this value has to be between $0 and $1,000 in amount. And then we could kind of automatically do that as well. So there are some kind of interesting ways for improvement. The other one, just kind of going out on a limb, is actually going in the reverse and saying, you have a Java class, generate me rules off the Java class to validate it. Well, that's a little bit of a harder problem, but still something super interesting. And if anyone is looking for fun computer science problems, definitely build something, share it with us. We'd love to see it. Cool. So we talked through that example of a user writing some more complex data. Now we know that our users are going to be reading from our information. So we'll do a similar exercise. We'll say, great, users can read all their own expenses. Everyone should know what this looks like. We're just going to say, yep, you can get a single document, or you can query for all of your documents, assuming that your ID matches the ID in that document, right? Remember when we created things, we had to ensure that those are matched. We're going to do the same thing on queries. And so this would prevent me from querying someone else's data, which obviously we don't want. And that's where we get to the first gotcha. And this is why Firestore is a little interesting, right? So you can imagine that we have, in our expenses collection, 3 different expenses. And maybe we have more than that, but we'll start with 3. And there are 2 expenses by me, user 12345, for $10 and $3.99. And then some other user has a $1.50 expense. So as you can see, that and then our other one is different. And so you might kind of natively expect that, hey, I have this set of rules that's saying, only give me my things. I'm going to query, and maybe I'm going to get only my documents. And that is not how things work, right? People get really tripped up here because Firestore is like, no, I can't feasibly give you only those things, right? Maybe there are only 3 items, but maybe there are 3 million items. And Firestore isn't going to look at every single document and be like, ah, yes, Mike needs these 3 items. So you may kind of reformulate that and be like, oh, I'm in development. All the documents are my own, right? I own every single one of them, and that's the only thing in the database. So you may do the same thing. You may say, hey, give me all those documents. They're all mine, right? And nope, Firestore still can't do that. And again, kind of what's happening is we have to know kind of beforehand if we can fulfill the request, right? So you actually have to say, hey, write a query that says, give me all of the documents where the UID is equal to, I hard-coded 1, 2, 3, 4, 5. But what I would do is I would pull my UID client-side off that token and then match that. And in that case, Firestore is basically asking this question, right? Can I prove that this operation will be allowed without ever looking at the data, right? Because if we had to look at a billion documents in order to return you one document, that would be an incredibly, incredibly slow database and an incredibly slow product. And that's not the promise of Firebase, and especially not Cloud Firestore, where we have to do tens or hundreds of milliseconds of sync time. And so the answer in that case is yes, we can, because you've provided information in the query that we match with the rules that you've written. So that's the concept that you kind of need to think about when you're writing Firestore rules, is we're validating it based on the rule and the query, not based on the underlying data. Okay, so I said that I'd come back to this. What about role-based access control, right? So we've been living in a world I won't go all the way back. But we've been living in a world with a bunch of different attribute checks, right? Of, ensure that the size is less than this and the UID matches this. But I think a lot of people conceptually think about things in role-based access control terms, right? You're like, I'm a user. Maybe I have a construction worker role, therefore I can access a toolbox, right? Like life just sort of kind of works this way. So RBAC, as opposed to ABAC, user, role, resource. And maybe there are cases, we've gotten a little more fancy in our application, and we work for a big enterprise, and they have admins who are checking our expenses, and we have to give the admins access to view our expenses to audit or whatever. And so we can write this little kind of local function and say, hey, if it's me, allow me to read it, or if this person accessing it is an admin. But how do we get to that kind of is admin check? We can do that in a couple ways. But the simplest is you can actually write this kind of little local function, isAdmin, and what it's going to do is it's actually going to look up data that is in the database. So you can create like access control lists in your database, or for instance, if you're building kind of like sharing information, if you're building a Google Docs or a Google Drive clone, you could say hey, these are all the people who have access to a document. In our case, we're just going to create another collection called admins, and hey, we're going to look up and say, is this user in the admins collection? And if they're in the admins collection, great, we'll allow them to be an admin. Which of course brings this amazing, interesting question of like, oh, well, how does someone get in the admins collection if doing so now grants them these magical powers? The zeroth order answer is the one that I commonly do, is literally just go into the console and copy an ID and paste it in. But that's obviously not super scalable. So let's imagine that we're going to actually use another piece of functionality of Firebase Auth and our integrations, which are called custom token claims. So a custom claim is something like we have here of an isAdmin flag. And if we go all the way back to that first section on Firebase Auth, we talked about that token, and we talked about the body. And within that body, there are a bunch of kind of normal claims, like my email. And we can augment those with custom claims. So we could, for instance, when that token is being created, create it with this additional flag that says, this person is an admin, therefore they can do another set of things. So you might be like, oh man, that's awesome. I can put all sorts of information. I can put, the company that they work at. You can put, group information. You can store profile photos. Don't do that, actually. I had someone do a 10 megabyte profile photo. Turns out HTTP headers do not take well to 10 megabyte photos in the header. And so we've kind of provided a couple limits on that, right? So custom claims aren't kind of a panacea for all of your authentication needs, right? We limit them to a kilobyte, so you can only kind of put static data and like small amounts of static data. And also, we don't want them to be heavily dynamic, right? These things are refreshed when the token gets refreshed, roughly once an hour. And so don't store information like the chat rooms that a user is allowed to access, because they'll still be able to access it for an hour, right? If you need small dynamic pieces of data, store that in something like Firestore in another collection, and do a lookup like we had with exists to actually look and see if that document exists. 2 shameless plugs. So Jen Person, one of the Firebase DAs, did a really good talk that dives all the way into use cases around custom claims, when you should use them and when you shouldn't. And then if you enjoyed the kind of data modeling perspective, yours truly gave a absolutely fantastic YouTube video, yeah, not biased at all, where we dive into kind of more complex examples. And then we also solve that bootstrapping problem of how does the first user get into a place. So we've written a bunch of code thus far, and I don't know about you. I know when I write my apps, I don't always test them. So I'm not going to ask people if they test their apps, but it's something that we all know that we should do, like brushing our teeth and flossing. And we're going to try and make it as easy as possible to do those things, right? So there are a couple ways that we provide to actually test that functionality out, right? I wrote a bunch of rules, and you're like, great, Mike, those look fine, but prove to me that they're actually secure. So that's what we're going to do now. So we provide the first tool, which is a simulator. And so a simulator is in our console. We allow you to, right where you edit those rules, actually test that those rules are doing what you think they're doing. So I've copied that exact same set of rules. Over on the left side of the screen, you can see, hey, we're going to try a create. And we can create a document. So I actually went to the taco trucks across the street, and so I don't have an expense for it. But imagine that cost me $10, and I took a photo of it. So the photo is stored over in storage, $10, my UID, remember that number 12345. Great, I'm going to build that document. I'm going to go down to the authentication section, and I'm going to put my UID in there, 12345. And then I'm going to click run. And run is going to say, yep, your read or your create to expenses/lunch has all those keys, matches, is less than $1,000, etc. But if, for instance, I just change that Firebase UID to 13579, so basically not myself, but I'm trying to, to write a document that has that, it's going to fail that write, and that's obviously by design. And the same would happen if I say, change the expense to $2,000 or similar. It would kind of give me that nice failure message of, hey, something's wrong. So it's a really nice way of doing that. If I drop the simulator down, it'll also provide a total version history, right? So every time I save and redeploy those rules, I'll have a version history. So I can kind of test that as I want. And then if something broke, I could, for instance, kind of, one-click rollback in the simulator, hey, get back to a safe state. But obviously, that's kind of nice for these one-off things. But ideally, when you're developing, you have a little bit, you have unit tests or an integration test. So we also provide a local emulator. And so the local emulator will basically allow you to programmatically do those similar tests. So you'd have your rules, and you have kind of your local database. You can read and write to it. And I can create, hey, in my expenses collection, maybe I want to go and fetch your expense versus my expense. And I've written rules that kind of do that. And then I can write assertions and say, hey, this test should fail under this set of circumstances, but maybe this test should succeed. And then I can validate those. So that's a really nice way of, again, getting more towards the automation of your security. Awesome. So we've talked a lot about kind of the deep technical aspects of how to secure your application. But there are a lot of things that actually I think are more common and more frequently done incorrectly that are much bigger security vulnerabilities. So I'm doing another talk tomorrow, shameless plug number 3, I guess, that goes really in depth on kind of threat models and threat environments. But basically the idea is there are threats in the world. Everything from the random people on the internet pinging your website to state-sponsored entities who are doing very targeted and specific attacks. And so in the category of threats, right, when you build an application, you want to kind of pick the threats that are most likely because those are obviously, they're more likely to occur, therefore you should kind of try and solve them initially. Unless, again, it depends on what you're doing, but generally understanding kind of the, what threats are out there, what tools may be used to break your application or have malicious things. One of the most common ones, and I think we call it, sort of insider risk or, unintentionally malicious behavior, is, everyone is really worried about this guy, right? The hacker who's sitting around trying to break into your app. But like, practically speaking, it's like this guy, from IT who like accidentally deleted everything. Like, that's a much bigger threat than, this thing, right? Like, much lower probability, maybe, a little more dangerous, but practically speaking, if this is going to happen 98% of the time because they clicked the wrong button, that is still a really big threat that you want to deal with. So, this Mike at McDonald.com guy, we don't know if we can trust him. I wanted to add him to my project. And typically, my alter ego is an editor, right? Or is an owner. I can do anything in this project. But maybe I don't really trust this other one. And so I want to give him kind of more, specific permissions. I don't want to give him full access to, say, all of my business data or, access to send push notifications. I want to say, hey, Mike, I'm going to give you a particular role. And we can actually go and say, okay, there are some analytics roles that are, reader or writer. There's maybe a developer role. And, Mike is going to be doing some development work for me, so I'll give him the developer admin role. So, he can go and delete the entire database, but he can't send push notifications to spam all of my users, right? So there's, some guide rails there. And if you need, you can kind of bump out of that into Google Cloud Platform and use the custom roles in Google Cloud Platform to create, similar to what we did for our IAM example, give, Mike at McDonald.com only access to a database. And maybe even, only read access to a database and write access to storage. You can kind of create whatever you want and give them that custom role, and the Firebase console will respect that. Cool. And the last one, again, kind of going a little more abstract, but developer experience is a really, really important part of security, right? Because if your processes are really cumbersome, right, if you, have a bunch of manual steps, people are going to kind of bypass them or, take shortcuts and end up in places where you've kind of unintentionally built vulnerabilities into your application. And there are a couple common ones that we see really, really often. Shared environments is a huge one, right? So for those of you who are running Firebase apps today, you may have things like, your dev and your beta and your prod apps all in the same project. And that means they're sharing an auth database. That means they're sharing an actual database. That means your metrics are kind of looking interesting. Projects are kind of a nice firewall between those, right? Because you want an entirely separate database that, if someone comes along and accidentally deletes it, that's fine, right? It was staging, you can rebuild it. And so really, really recommend that. And I think there are a lot of people who say, oh man, it's really hard to set up environments because it requires a lot of manual toil of enabling all of your APIs, et cetera. So tools like Terraform or Deployment Manager will help you kind of build that infrastructure. So the infrastructure as a code type thing will help you do that easier. And related to that, right, like if you have a very manual tool chain, a lot of times, people will do things like, they have, for building an iOS app, have like the one Mac Mini in the corner of the office where they like build the app on and then, put a thumb drive in and take the IPA file off and walk it over to another computer to upload it to iTunes Connect. Like, that's a really bad experience, and you're likely to, copy the wrong file or do something like that. And so CI or CD tools, so using Cloud Build, or we have a really great mobile tool called Fastlane, which does things like automate, provisioning profile signing and upload to the App Store, and kind of doing that, securely. So not everyone at your company can say upload an APK to the App Store. Only, the Cloud Build deployment agent can do that. You can kind of build some additional security in there. Okay, so that is all I have. I have about 10 minutes. If you have questions, I am happy to answer them. And I will stick around after as well. Otherwise, please submit your feedback. And if you have other questions, I'm on Twitter at ASCIIMike, ASCIIMIKE, and would love to help you wherever you are in your development journey. Also, if you've built awesome Firebase apps, send them my way. Send them to Firebase on Twitter, right into support. Again, I love seeing what you build, and I may try and break it and give you feedback on that. So thank you all very much for coming, and enjoy the rest of Next.